But yeah, hi, my name is Mittal. I'm the CEO and co-founder of Locofy.ai. We are a Singapore-based startup that is very passionate about front-end development and making tools that allow designers and developers to build delightful experiences. And I'm here to talk to you about large design models, something that we've created, and we bet on that being the future of front-end development. But I think before we get into design models, let's first talk about a problem that I'm sure if you're product managers, founders, engineers, you would have felt this problem before. Okay, so there's no secret, of course, web and app development, markets have been growing like crazy, and that's reflected in how expensive it has become in terms of hiring engineers. And I think these numbers, not only hold from the pre-AI sort of explosion era, but since the AI boom, many believe that this market is going to get even bigger now as many people come into the space. And earlier, it used to be only tech companies building for building tech products. Today, it's everyone is trying to be a tech company, and everyone's trying to hire engineers and designers. So the extent of this problem was felt obviously throughout the world. We felt it ourselves. Before Locofy, I was the chief product officer in three startups in Singapore, and I was hiring engineers and designers, and I saw firsthand just how expensive it was becoming. And as an investor advisor to some startups, I've also seen that not being able to hire good engineers and designers was the reason why a lot of companies were failing and losing revenue opportunities. And 10 years ago, you could hire good engineers in low-cost markets. India, Vietnam, Romania. There's a few of these pockets, obviously. But now, as the Indian economy, the startup economy starts booming, it's becoming increasingly expensive to hire engineers offshore as well. So we felt this problem ourselves as builders, and we thought, this is something we want to potentially tackle. But on the ground, if you are a designer, engineer, again a product manager, you would have felt some of these problems, I'm sure, right? Agencies have always said, and freelancers, that our clients want things done faster and cheaper, and it's becoming super expensive, sorry, super competitive. Engineers obviously have been the most prized resource in fast growing startups and tech companies, and increasingly in non-tech companies as well. um, Despite spending tons on engineering and tech, majority of the products out there are average at best, especially when it comes to front end experiences. That's what we care about. And the last one, especially, this is something, if you're a designer or engineer, I'm sure when you go from designs to code, the amount of time just wasted between designers and engineers, the back and forth in building front end, is something I've felt myself, and I've been in the middle of designers and engineers as a product manager as well. And that's just something that doesn't make sense, and it's not a fun experience to be part of. Let's dive into that, right? Like, this is something a lot of us can potentially relate to. At the start of the project, things are super exciting. At the start of the project, everyone feels like they're onto something. They have a potentially brilliant idea that can change the world, a potentially brilliant idea that can change the course of a company. People start very excited and get together and start getting their ideas into potentially a paper, a fig jam, or a Jamboard. um, and that idea starts developing into something that people can see and start feeling like this is something we want to get to our users quickly. So they get together with you beautiful designers, and designers are obviously amazing at bringing these ideas, abstract ideas, or paper based ideas into brilliant mock-ups. And after that, you're like super excited, let's get it out to the market, let's change the world. And unfortunately, after that starts these thousands of iterations, at the end of which, by the time you get the product, it is nothing like what you had imagined. And oftentimes you spent millions. You potentially waited for 6 to 9 months, or a couple of quarters. In big companies, it can be even 1.5 years. After which you realize this product is nowhere close to what you had imagined, and now you have this dilemma of, should I launch this product, or should I go back to the drawing board and cut my loss? Should I cut my losses and just launch it, or should I go back and do what I was supposed to do in the first place? And at the end of the project, most people are ready to kill each other. A lot of people are ready to give up. and whatever little hope they had of changing the world starts fading away. um, this is essentially what we faced before, and we started asking these questions to ourselves about 4 years ago. What if we could get these designs into a pixel perfect web app or a mobile app as quickly as possible? That's cheap, fast. It gives designers the control over the end user experience. It frees up engineers to work on the real complex logic part and the business innovation rather than writing front end code from scratch. And this would help solve all these problems to some extent that we've talked about. No one I know today, even the best of the best companies from Silicon Valley or the best tech companies, fine companies, would say they are happy with the speed at which they're innovating. Everyone's looking to build faster and build cheaper and launch faster. And we thought, this would be a great problem to focus on. And the way we thought about this was, again, 4 years ago, this was a crazy idea, but today it seems a lot more normal. We thought we are going to build the largest, design models the world has ever seen, that would understand designs the same way as a designer or a front-end engineer or a product manager understands, and brings them to life by just purely understanding designs from the point of view of layouts, frames, grouping, auto layout, of course, but also HTML tags, semantically correct tags as well, UI elements that appear again and again, and components, and also media queries, and brings it to life. And we started building these design models about 3 to 4 years ago, and that's essentially why I'm here to talk to you about. So, in a nutshell, what Locofy does, and I'm sorry if you can hear the background noise near my house. There's some construction going on. Sorry about that. But in a nutshell, what Locofy does is it fits into your existing workflows using our large design models as the bedrock, and it converts your Figma designs into code. And our vision was it can be any design tool, it can be any design framework, any design library, literally any design patterns that engineers and designers are used to, or even platforms, and bring it to life. And that life in that case could mean a web app or a mobile app built on any of these frameworks that you can see over here, with any code settings that engineers and designers want. We know how much designers and developers love their own set of tools or set of settings, and it's very hard to ask them to change. And why should anyone in the first place? And we believe that our design models should be able to adapt to the preferences of the designers and engineers and bring them to life, and also fit in, of course. But because who wants to change your workflow, right? It should ideally fit in between your existing tools, existing stack, existing platforms, and speed you up rather than slow you down. So before I dive into how we built our design models, I want to show you what Locofy looks like in a nutshell. So this is a quick video that shows how, once you're done with your Figma designs, this is obviously Figma, and you're building, let's say, an Airbnb-like app. All you have to do is essentially open our Locofy plugin, which runs on our design models. It understands your designs, scans them, runs a bunch of things that an engineer would, and generates the code within a few seconds. And then what you're seeing on top over here is a preview, a live prototype rather, that is running on the code itself in your preferred settings. Of course, no AI can be perfect, and we don't claim to be there, but we also at the same time use um, our North Star metrics internally is to get to as close to perfection as possible, and then also make it easy for engineers to correct what is wrong. So it's a combination of automating as much as possible, but also providing diagnostic tools to help you improve and also to learn from that, so that you're not doing the grunt work of writing UI code and fixing CSS. And it also gives you the power as a designer to see what that end product would look like before your engineers have to spend time on it. So I've talked about large design models. So let's talk about how we built it and how they work. But of course, there's a question that I'm sure you would have, and a question we've been asked by hundreds of people. Um, why not use LLMs? LLMs have, obviously changed the world in many ways, and they continue doing so, and they have evolved. And we love LLMs and LMMs rather as much as anyone else. We are as excited about it as anyone else. when we started building Locofy, ChatGPT, OpenAI, Stable Diffusion, or rather GPT-4, GPT-3, ChatGPT, Stable Diffusion, and even GitHub Copilot had not launched. So for us, it was very much about understanding a designer's world from design models point of view. When the LLMs were introduced, we were super excited as well. We have played around with them, love them as much. But the reality still remains that when you feed a design into a popular LLM like Gemini, it does not understand designs. Claude also does not understand designs. You can pass it some images sometimes, and ChatGPT actually used to do a good job, and it's getting better in many ways. But what you get in return is nowhere compared to what you had designed in mind. Started with the design in mind itself. So Locofy was built obviously for one thing only, which was understand designs and convert it into your front end code and bring it to pixel perfect, prototype as quickly as possible. Um, and the reasoning behind was very simple. Large language models are obviously built on trillions and trillions of like books, articles, tweets, ebooks, and increasingly with images and videos, a lot of content, and they obviously understand that better than anyone else. But design models were built on the bedrock of understanding a different kind of language, which is a language that we as human beings have been speaking for even longer than maybe English, right? It's the language of designs and shapes and vectors and symbols. And today, even till today, they show up on the products that we interact with on a daily basis. So when you see a home icon, or when you see a shopping cart icon, or you see a heart icon, you instantly know what that means. And that's the language that we wanted to train our design models on. So, like I said, these design models are trained on more than 500 million design parameters. It's a combination of Figma design files, openly sourced, websites around the world that are openly sourced as well. And we also wrote some automation of taking, a design and like creating hundreds of variations of that by changing a few things, whether it's padding, language, color, shapes, sizes, tons of parameters I'm sure designers and engineers can relate to. And we've trained our models in ways that I will show you later. And we've also written a white paper about it, and are in the process of writing a research paper as well. So, in a nutshell, this is what our design models look like. On the left-hand side, you see is a design. It could be a Figma design, and in future can be any design really, mobile or desktop, or from any platform. Could be Figma, could be Adobe XD, and the newer age design tools that are coming up, or the open source tools like Penpot. We are working with pretty much all of them now, and bringing them live as we speak. But this box that you see, we start with something called foundational design models, where we take Figma data and we take inputs and a bunch of other input parameters. We then pass it through what we call a design optimizer to fix your designs and structure your designs properly so that the output is better. Then we do something called tagging and feature detection, which is identifying these UI elements, the atomic HTML elements, but also other UI elements that are commonly seen across, things like carousels, for example. Then we find components so that you're not working with messy code and it's more modular and reusable. Responsiveness, of course, is the toughest problem out of all, I would say, and we will dive in a little bit later. And after we've done with this design model flowchart, at the end we also integrate with an LLM, which is just a beginning of a bigger partnership, where we take your layer names that designers may not have named properly and convert them into more human readable class names, which will appear on your code, of course, which makes it easy to collaborate on and maintain. And at the end of it, we get you the code and a preview that runs on it. And earlier, what you saw in the demo was about 15 to 20 seconds. What was running behind the scenes was basically this large design models, and they are evolving as we speak. So let's go through it step by step. The very first thing is we scan your designs. We go through your Figma metadata, node metadata, images, text, and we convert that into a large embedding. That's what we call our foundational design models. And that becomes then the bedrock of running multiple different models to solve different problems. We do this using the transformer architecture. The next step is design optimizer. Like I said, when we started Locofy, we didn't think people, or rather we assumed that the whole world of designers would follow design practices, the best design practices, and remove unnecessary groups and layers, and like group things properly, apply the right padding, apply make it consistent, and apply auto layout and the right constraints. But when we started working with startups, we realized that because startups work in such a rush, and we've been there ourselves, we don't necessarily get the time to follow the best practices. We care more about the actual design itself rather than the layers and the nodes on the left hand side. And then we realize one way is to obviously train engineers and designers to follow best practices, but the other one is to build a model that actually goes and does 80% of that work, in terms of ungrouping everything and grouping it back the right way, so that auto layout and auto layout settings work properly, and we also remove unnecessary groups and unnecessary frames as well. For this, we use visual transformers and name entity recognition. So a before and after could look something as simple as this. On the left-hand side, you see, in the middle is obviously the design, and the design looks amazing. But on the left-hand side, you'll see that maybe the grouping is not done right, maybe auto layout is not applied. But after passing it through the design optimizer, you'll see that the structure has been optimized. We've applied auto layout, and we've also grouped things properly as well. So that's step one. Step two, we go through something called tagging and feature detection, where we basically scan your design and look for all the HTML, like inputs and buttons and date time pickers, and also go down to an atomic level and look for headers and the right kind of sections and images. So if you see on the top section, there are about 5 rectangles. They all have they're essentially all a rectangle, and they have a text and they have an icon. Yet all of them are different, because the first one is uh, um, an autocomplete, the second one and the third one are daytime pickers, and then we have an input and a button. So we've trained our models with millions of such design files to understand the difference between them. It's not only based on image classification, it also looks at the text and the surrounding information around it, and then makes the prediction. And then the next thing it does is it looks for if it comes from an existing public library. Sorry, let me just go back. That was accidental. But yeah, it then looks for a library, whether it's from Material and Bootstrap, or possibly your own design system as well, on a local level. And it does that for about 40 plus tags, and these are some things that we keep investing into. So we are looking at tons of data out there, annotating it, training our models to understand the difference between different UI components. But recently, we've also started something called feature detection, which is identifying things like carousels, tabs, and bottom tabs, and navigation drawers, hamburger menus, for example, where we know that these will show up in different designs, and at the same time, when they show up, we don't want you to write the code from scratch, at least, and help you as much of the UI code as possible. Then comes code components. Of course, what designers call components and what engineers call components can sometimes differ, but the idea is the same, which is go through your designs and identify elements that are repeating. So that in this case, if you see, we have something called a hotel component. It's obviously repeating, and you'll see this pattern repeating on tons of different websites, not just travel websites and apps. But we find out that, look, this looks similar to everything else. And instead of giving you like 1600 lines of code, we will do 100 lines of code times 16 by converting it into a modular component. But then anything that is dynamic will then become a prop, such as its image, the name of the hotel itself, the address, the price, and the rating itself. So this is all done by understanding what you already call a Figma component. But if you haven't already done that, we also look for similarity detection and convert your design into modular, reusable components and props. Lastly, responsiveness. This is, I have to say, one of the hardest problems we've ever worked on, partly because there are no real global standards and it's very subjective, and also partly because we just couldn't find the data of websites and apps done properly to be able to train our models. But the idea behind it is very simple. Not just respect what you've done on auto layout, but also try and make your website and apps fit onto smaller devices, tablets, mobile. But of course, because it's responsive, it's important for us to do the best we can and then let our users be able to change it to their liking. So for example, in this case, there's a form that is very like horizontal and it goes vertical in this case, but I have seen examples of this where you would just see 4 icons and it will still fit on a mobile device, but would be reduced into just icons that expand. And there's no right or wrong when it comes to responsiveness. So for us, we try and follow the most popular patterns. And in future, we plan to also provide you options of how you would want this on a mobile screen. There could be 3 or 4 patterns that we recognize, and you can choose any one of them. And lastly, like I said, LLM integration. This is something relatively new. We realize that designers don't often name their Figma layers properly when they're in a rush, obviously. But when converting those designs into code, those layer names have a more important meaning. And if we ask designers to do that, they may or may not have the time to go back and do it. So why not use an LLM and pass the right context and get the name of the layers properly? So in this case, you see on the left-hand side, I'm sure you can relate as designers. Beautiful design again, but named as group 20190, whatever. But with the right context, it could be an action bar or a button, or it could be an input destination. And we recently did an experiment with Gemini, and we were showcased at Google I/O, and we were also part of their Google Accelerator. And this became the starting point of something even bigger. But anyway, so in a nutshell, what you saw in the 20 seconds, this is what happens. But of course, we are not done yet. This is just the beginning. We only launched our design models earlier this year, and since then we have improved, the preview match and the pixel perfect sort of match between your design and preview from 40% in January to now 92%, which means for 92% of the times, every element we are identifying it properly and rendering it properly with the right tags and the right information in code. The way we do this, quite straightforward. We take HTML data from millions of websites around the world that's publicly available, and we also take Figma data for some data sets that we've created, some designs that we've created, and in sometimes community files that are available as well. And we go ahead and label data, and we break it into a training data set and a test data set. We break the training data set into a foundational model, which is a combination of image embeddings, text, and metadata. And then we break it into different model trainings for design optimizer, tagging, components, and feature detection. And then when it comes to evaluating, of course, data scientists have their way of evaluating, like how many times were we able to identify a button as a button. But we also look at our own evaluation metrics, something that we call preview mismatch, of seeing the overall design and then the code that generates the when we render it in the browser, then we compare each and every node and see whether the x-axis, y-axis, the positions, the widths, heights have changed or not. And if it has, even by a pixel, we count it as a preview mismatch. And if you have more than 5% mismatch, we count it as a fail on our side. And that obviously then goes back into understanding what went wrong and how we can improve our training data set. And then, of course, on the inference side, when you use Locofy, we take your Figma design and we convert it into a design format that we understand, the Locofy design data. We had to create a common data set because in future, this will not just be Figma designs, but other design tools as well. And they need to map onto a common format on Locofy's side, which then we send through our inference, where we get outputs. This output is not the code itself, but it's output from each of these models, which together with also the layer names that we get from an LLM, then go into our code generation engine, which is completely non-AI based. It's purely heuristics. And then we generate the code based on your settings. So if you have React with Tailwind, or you have Angular using JavaScript versus TypeScript, we apply those settings in the code generator, and then we give you the code itself. And of course, we don't claim the code is perfect, but it's 80 to 90% there, and we give you the diagnostic tools to improve that code or even export it into your environment. It's not a no-code approach; it's a low-code approach. So what you saw so far was, how design models can convert designs into front-end code, and this has been, I would say, it's been 4 years of our careers, and potentially the next 10 years. We are super passionate about helping designers and front-end engineers do this via our design models. But we also believe that when we convert your designs into code, LLMs can actually play a bigger role in improving that code even further because they understand code better than Locofy does. And that's why we believe that LDMs and LLMs working together will truly be front end development and software engineering as a whole to the next level. Uh, we had this hypothesis a few months ago. We tried it with layer names, as I showed you earlier, but then we joined the Google Accelerator to with the idea that once we generate the code, it's not perfect. Can we refine the code? Can we add backend logic to it? Can we add API integrations? Can we do data binding? Can we also make English website work on hundreds of other languages without having to go through that effort? Any designer or engineer listening in would understand, would know the pain. Any SDK integrations, the list goes on. There's no end to front end development. Accessibility, for example, UI testing, performance testing. There's just so much that can be done in this space that design models alone will not solve. And that's where we feel design models and LLMs working together is the future. And some of these popular design models have also, or builders have also seen the potential, and they've been interested in not just partnering with us, but also acquiring us, which further proves that we're on the right track. So I already, I think, showed you what layer names looks like, but this is purely focused on that. On the left-hand side, you see the frame names. Oftentimes designers don't have the time. It's not that they don't want to, but just don't have the time. But using this integration, we are able to look at the context and say that, hey, this frame 0102 is actually something called listing items, which can then show up in your code and make more sense. Similarly, engineers obviously add comments to their code. When Locofy generates thousands of lines of code, we don't produce comments. But using an LLM, we think we can easily pass the context and get comments, which will make it easy for not just the engineers to understand what Locofy has done, but also their colleagues and collaborators to understand when they're collaborating. And lastly, this is something we're tinkering around with. We only produce front-end code, UI code, but let's say I want to add logic to it or add scripts to it. With the right context and with the right LLM model, we will be able to produce the backend code, potentially, do a lot more with it. This is just a sneak peek, but we do plan on adding a second layer, which is one click to go from designs to code using our design models, but then providing a chat-based interface where you can say, hey, I don't want this form to go stack up. I just want it to go become a slider in an English format, obviously, through prompt engineering. And that's something we're super excited to build on top of our design models. So like I said, we think not only large design models, but the combination of these models out there would be revolutionary when it comes to software developers and builders and startups and big companies. We will play our part in terms of scaling our own design models. We've only gone about 500 odd design parameters this year, starting from 100 million in the early days. We want to scale that. Of course, scaling laws will apply over here as much as anywhere else. And both in terms of compute and in terms of data, we are going to go really deep into it, especially as we see our early efforts show good results. We also want to do the same for mobile apps. Currently, our one-click design model approach only applies for web products, so Angular, React, Next.js, and all. But we think we have the infrastructure now in place to easily do that for mobile apps, whether it's React Native, Flutter, Jetpack Compose, Kotlin, Swift UI, anything. We should be able to do that easily with our code generation because there's a lot that's common that we've already laid the groundwork for. And we also obviously want to scale this for other design tools. I talked earlier about a common design format that we have built. It was a painful process, but the reason why we did that was so that in future, when we want to launch it for another design tool, it should be very quick. It should not take us the same amount of time that it took for Figma to React and Figma to Angular. We want to supercharge feature detection because we think it holds the key for fixing or improving responsiveness tremendously. We may not be able to make your website perfectly responsive today, but if we can break it down into smaller components like a gallery, I don't know, a profile photograph side, a video, a search bar, if you can break it into smaller components and understand their behavior on a mobile device versus desktop, we are most likely going to be able to solve this problem better than just taking a look at the entire website and trying to make it responsive. So we're going to go very deep into it, and on a monthly basis, we are launching the feature detection for at least 3 to 6 new features such as headers and footers, carousel, accordions. Now we're working on tab galleries and tables. And we have the infrastructure. It's just about getting the right data and training our models before we bring them to production. And lastly, like I said, the combination of LLMs and LDMs working together is something that we are super excited about. We're only scratching the surface. This is something that I would, even invite feedback from not just our community, but people from the ADPLIst community as well on what do you think is possible for these models working together. Um, we are super passionate about this topic. We think front end is something that doesn't get the kind of attention that it needs. We were lucky to build some of the earliest editor's choice apps from Asia. In fact, the first editor's choice app on Google Play app was ours, other than a game like for non-games. That was 10 years ago. My co-founder and I were lucky enough to build it. Then we built another one, which was in the top 5 standout apps on Google Play globally. Then we won an App of the Year award from Apple. Then we got a progressive web app, which was built in 3 months. That was even showcased at Google I/O by its senior leadership. And we realized that this is something we are passionate about, we are good at, but a lot of companies struggle somehow. And we were very clear that in a world today where cars can drive themselves, and we're talking about going to Mars and all these excitements, obviously in the AI field, how is it that 9 out of 10 websites or apps that I visit today are still they still look like they were built in 20, 30 years ago? Um, Part of it is, I think, solvable by tools like Locofy, and that's why we went on to this mission. We've written a white paper about how it works. We've been doing this for 4 years now. There's a research paper coming, and we will invite researchers, designers, and front-end engineers and mobile app engineers to come in and collaborate in any shape or form. We're also thinking about open sourcing some parts of our design models potentially to see what the community can do with it. But yeah, look, we are at the end of the day, we are also a young startup that has just come out of free beta, and we will make certain bets every now and then. Right now, we are fully focused on building the best of these models as we can ourselves. I would love for you guys to try Locofy, especially if you're builders. If you're not already doing so, we were in free beta for the longest time. We've just recently, just 2 weeks ago, come out of free beta, but we are offering the ADPLIst community this exclusive discount of if you get an annual plan, and if you're a student, we love students. My co-founder and I, we are both our parents, are teachers, and we were very clear that for students, we will keep offering them free tokens. Currently, we are only doing 1,000 free tokens. But at the same time, for anyone asking for more, we are more than happy to upgrade and not make students pay for it. So yeah, that's about it for my talk. Thank you so much for the opportunity. I hope this was insightful, and I'm happy to take questions as well. Okay, let me just see if we have a question. Okay, I think I have one question over here. What new skills will developers need to adapt? That's a hard question to answer because I think the answer for that has changed quite a bit in the last 6 months. Every time I've talked to a developer in my team, or even asked this question from other developers, and I think the answer lies in that statement itself. You have to be able to adapt. You have to be able to challenge yourself and unlearn and learn some things while still staying true to who you are. Engineers are really good at breaking a problem down and being able to automate things to essentially lead to insane amount of impact. And I think right now the world of obviously development is changing to the point of like, hey, is the programming language that you're used to even the new programming language, or is it just going to be plain English language? And the amount of tools available out there in the market can also obviously be very overwhelming. I think the best advice I can give in terms of what an engineers can do or the kind of skills they can pick up is be in tune with all the tools out there, of course, but don't get too bogged down by that. Or the last thing you want to do is be scared by it. Engineers will always be in demand. I think there's only 30 million people who can code in the world today available, and pretty much everyone in the world wants to build something. So that should tell you about how big the gap between the demand and supply is. Of course, with LLMs, it becomes easier for people to come in and build, but just because it becomes easy doesn't mean it removes the engineer from the loop itself. The years of experience you have building and understanding what happens behind the scenes when you ask an LLM to build a controller, for example, will still take you a long way. But at the same time, like I think for engineers who are completely um, against what is happening out there, and to some extent in denial, and to some extent they feel, they've seen many of these cycles that claim things will change and they don't. I would still say I think this AI wave is definitely different, right? Like it will be um, unfortunate if you don't pay attention to the world of AI out there, whether it is in terms of how you build your whole apps or certain parts of your workflow, whether it's building front end or whether it's doing your research itself, or the way you close your tickets, or the way you QA your own code. Uh, it's best to be like an early adopter, because that could potentially give you and the organization you work in the edge when compared to others. So I don't know. Look, I'm at the same, like I'm an engineer at heart, but I haven't written code in the longest time. I went from writing code to becoming a product manager, but I work very closely with engineers. Good engineers will always stay in demand. I don't see good engineers getting out of business anytime soon. But good engineers stay good engineers by adapting to what's new and what's going to give them that edge in terms of productivity or in terms of the quality, or both. Cool. Um, I don't know if there's any more questions here. Maybe I check once with
That's
the
all.
host.
That's all for the Q&A as of now.
Okay.
So yeah, in case if you have anything else to share, you can share that. Otherwise, we're good to go and we can wrap up the session then.
No, I think I'm good to go. Thank you so much for the opportunity again, and hope you guys have a good, rest of the BeMore Festival. Thank you so much. And I'm obviously available on LinkedIn. You can reach out to me at honey@locofy.ai if you have any ideas on how we can improve Locofy better, or make it part of your own workflow as well. But yeah, thank you so much. Have a great day, guys.
Okay, thanks a lot, Hani. Thanks a lot, everyone, for joining in. There are still other sessions that are running up in this slot. Otherwise, we'll be resuming in the next 20 minutes. Thanks
Awesome.
again.
Thank you so much. Bye bye.
Happy BeMore Festival. Bye.
Bye.